All right, so in this video, we're finishing up the problem where they're asking us to find the probability of getting just one white marble when we draw 3 marbles from a bag of marbles without replacement. And we discussed why this is the equivalent probability statement. I just want to point out that the word or here is appropriate because we can accomplish this, in other words, getting one white marble either this way or this way or this way. And so what the ors mean is that we need to add these cases together once we figure out the value of each of them separately. So let's start by figuring out this one first. There are 3 marbles being selected, so we're going to need 3 fractions of probability, right? And whenever we have more than one event, or whenever we're selecting more than one item, we can multiply the probabilities together in order to find the overall answer for that. Each one of these fractions is just basic probability, so this would be number of over total, right? And likewise, this is number of over total. And this is number of over total. And then from here we need to think about what? The number of ways you can get a non-white marble. So the number of ways to get a non-white marble is basically the same as the number of non-white marbles, right? So I'll say the number of ends for non-white marbles over the total number of marbles, right, that are in the bag. Now for the second fraction, it'll be the same thing. Total of non-white marbles or ends out of the total number of marbles, right? So we'll just dot, dot, dot that part. And then same for the last one, except for instead of total number of ends, this time we'll be looking for a white marble to occur. So we're going to say total number of W's, right? Or white marbles in the bag divided by the total number of marbles. All right, great. From there, we can go ahead and figure out these numbers pretty easy, right? So it said in the bag that it contained, let's draw the bag over here. Okay, so the number of marbles that are not white are going to be essentially the 2 here added together. So 10 red and 15 yellow make a total of 25 marbles that are not white. So we'll do 25 ends, right? Divided by the total number of marbles. Now, the total number of marbles, of course, here is 30 initially. Now, when you look at the second fraction, this is really going to be the total number of non-white marbles, right, left, I'm going to say, inside the bag, because we would have taken one of these non-white marbles out in the first step, right? And we put it aside, and when we go back in, since it's without replacement, these selections, there isn't going to be as many non-white marbles available. So we'll only have 24 non-white marbles available. And likewise, it'll be the total number of marbles also left here in the denominator. In other words, since we took one out in the first step, we'll only have 29 total marbles to draw from. All right, then we'll repeat that process for the last fraction. Number of white marbles divided by the total, and in this case it'll still be the total left. Now, number of white marbles, we won't have taken any white marbles up to this point, right? Because we assumed the first 2 selections were both non-white, so we'll still have 5 white marbles in the bag, but we will only have 28 marbles at that point when we went into the bag to take out the marble, right? Because we took out 2 marbles prior to that. All right, so that's your answer for the first one. Now you should do plus and then repeat it for the next one. So now we would try to work out the non-white, white, non-white case. But if you look at it, it should be very much the same. The reason why I say it should be very much the same is because when I first go into the bag, the probability that you get a non-white marble should still be 25 over 30, right? Because there are still going to be, at that point of the problem, right? We're starting over, basically. We're looking at the case that's over here. And, you know, we're basically reaching into the bag for the first time. There are 25 marbles that are not white out of 30 total marbles. Now, from there, the next marble is supposed to be white in this scenario, right? So the next one would be a white marble. Well, that probability would basically be 5 white marbles over a total of 29 marbles. So you may say, oh, well, that's a little different because here the 5 was up here and then the 29 was over here. But it actually doesn't matter because in multiplication, you can multiply in any order. As long as we get 24 and 28 in this last fraction, it'll be the same exact thing as the first one. And you'll be able to see that that's going to be the case, because what's the probability we get this non-white marble in the last selection? Well, think about it. In the first place, we took a non-white marble out, right? So one of those is missing. That means there's only going to be 24 non-white marbles left. And how many total marbles in the bag? Just 28, because we've already taken 2 out. So if you look at the numerator for the first thing that we wrote, we had 25, 24, and 5, right? We still have 24, 5, and 25, the same 3 numbers. And if you look at the denominators here, they're the same. So all we have to do is say, okay, the last one's going to be identical to this one. It won't actually matter the specific order that we write these fractions. It's going to have the same value. So I'm just going to sort of do dot, dot, dot on that to say the last one is the same. And what that actually means is you could solve this by a little simpler process in the beginning. You could have recognized that they would all be the same except for essentially where the fractions are located. And that meant that we could have said, well, there's basically just three cases, and they're equivalent to the 25 over 30 times the 24 over 29 times the 5 over 28, right? Since multiplication can occur in any order, these three things that I was writing out above, right? So these three here, that row is basically going to just be three expressions added together, right? So we can actually just shorten that by putting a 3 out in front and only working out one of the three cases. So another way to work out the problem is to actually do something very similar to what we just did, but to say instead that we're looking at the probability of getting 2 non-white marbles and 1 white marble. And so it's the same thing we were talking about before, but what we're going to do is use combinations to come up with the 3 that was out in front over here. The rest of it is pretty much identical. So 2 non-white marbles would be literally, 25 over 30, because there are 25 non-white marbles out of 30 marbles. Once you've taken one of those non-white marbles, there's only 24 of them left for the next selection out of only 29 total marbles. And then lastly, the last marble you take is going to be white. So that would be 5 over 28, right? But then you have to think there are multiple ways this can occur. And the way you can think about that is to think about it as a combination. And you can say, well, out of 3 marbles you're going to select, you're going to choose one of them to be white. And that's how you end up with the same 3 that we had in this way to solve it above. Because 3 choose 1 is just 3. And then you end up with the same answer, 25 over 30 times 24 over 29 times 5 over 28. All right, so there are 2 suitable ways to solve this problem. The main idea here is to remember that the order in which you take the marbles is important, right? So it's not just the colors involved, but it's the position in which they're selected. And the other thing to remember is that, of course, the with replacement or without replacement matters greatly, right? So if it was just, with replacement, we could have done this problem a little bit differently, but here it's not with replacement, it's without replacement. So we're pretty much left working it out in one of the 2 cases, or one of the 2 ways that we did here. There's no real shortcut beyond this. So I think the combinations way that we did it, the second way, is perfectly fine. So that's this solution, but also this solution is just as easy as long as you recognize that each of these are going to be the same, right? So there'll be 3 cases, but they basically are the same when it comes to the actual value of the product of those 3 fractions.